Good morning. This is Mr. Anderson, and today we're going to have a lesson on reliability. Reliability. The big deal with reliability is you already kind of know what that means. More reliable, not reliable. For instance, if you have a friend of yours who always flakes out, you would consider them not reliable. If you had a friend of yours who was always there that you called, and every time you called them, they picked up the phone, they would be considered more reliable. Okay, now, in statistics, the reliability is how you trust. And we always discuss it in terms of information. Okay, there is some information given, and it's how you trust it. Now, everybody is going to have a different level of reliability in terms of that. Now, we move on to the next word, which is, or I guess phrase, measure of reliability. When you discuss a measure of reliability, what you're really discussing is things that you need to know in order to basically check it off. We're like, okay, is it a well-established company? Has it been around for years? I'll give you an example. For if you go to the store and you go to the store and you see a pair of Nike shoes, you see a pair of shoes that you get from Payless, which would be maybe some Skechers, maybe some Vans, maybe some, I don't know, some Target brand shoes. My point would be, you could order that in terms of your mind. You could order that in terms of, okay, reliability in terms of quality. Okay, I give a check here. It's got quality, quality, quality. And then you can start checking them off. And then what you do is use all your check marks to create a measure of reliability. And this is normally given as a number, but you want to check the reliability of a statistic because you want to know whether or not you should trust it. And that is for you, the statistician, whether or not you should trust what is being told to you. Okay, and so it is a value assigned, to a statistic. That's nice. Oh, great. There we go. Okay, now I'm going to have you hit pause here. And what I want you to do is open up the video for the weather report. What in the weather report gives you the inclination that they know what they're talking about? Now, I like to come back and I like to discuss this information. And now you can get current pictures. And what you look at when you saw that weather report, they gave you what they called the forecast. And then they looked at what was going to happen that day in terms of the air quality. In terms of the air quality, they gave you current pictures. They used technology. All the little dots in there, you could assume very clearly that those were spots where they were reading the air quality at that particular area, meaning they didn't have dots in every single spot. They didn't draw a map over the whole thing. They gave you values where you was reading the air quality at that particular point, so you could feel confident in that. It was on the news. The news is one of those avenues where we get information that's supposed to be broad and structured. they had a timestamp on there so you could kind of follow what time it was. They had a sign at the bottom that told you what network it came with. Okay, all those things led to reliability. You felt more confident in looking at what they were saying because of that. And even though you know that they put all of this into it, there's still an area where it may not be accurate. And why is that? That is because we're talking about inferential statistics. It hasn't happened yet, so they can only be as good as they can. You're never going to be perfect. Now we cut to an inferential statistic. What that means is, for an inferential statistic, what you're looking for is something that you can tell in the future about using something that already happened. So, for instance, inferential statistic would be using descriptive data to inform future. And it could be future statistics is a better way of saying that. Output data. Okay? So we're going to use descriptive statistics to inform future data. And that would be an inferential statistic. Now, how this works for us is the reason why we study statistics is because we want really, really good information on inferential. For instance, our plan is when we get earthquakes, no one knows what's happening. Well, what do you want to do? We want to get as much data as we can to figure out if we can calculate or figure out when the next real big earthquake is going to be. If we knew that and we could give people advance warning, you would save lives. That is one of those big deals for inferential statistics. Okay. Same thing with the weather quality. Well, if I didn't let you know it might be a bad weather day, then you might go outside thinking that like, oh, okay, today's a nice day to start. And then you come back and you're like all coffee and congested because you were outside all day and the weather and the air quality got bad. Inferential statistics generally create a scenario where you can save your life. Okay, now, what we're going to do from here is we're going to discuss the difference between descriptive and inferential in terms of elements of what you need to have. Now what we're going to look for are what we need if you're doing a descriptive statistic versus what you need if you're doing an inferential statistic. Now, they're both the same to start. They both need a population of interest. Okay? What are you looking at? What do you care about? Okay? They both need variables. Okay? Now, where they start to differ is the only thing descriptive is looking for is like, okay, give me a table of my data graphs or give me summary of it. Okay? And then I can check for the pattern. Okay? Now, with inferential, it's slightly different. Because I'm doing inferential, meaning I don't have a full grasp of the whole population because I don't know what's coming, you need to sample it. So I'm going to look at some group of the data or sampling of the data. What I'm going to look for in the sampling is tables, graphs, and summaries and patterns. But my point is I need to look at a sample. I don't get the whole thing. Here, I get the whole thing. Okay? Now, from my sample, I need to then actually make an inference. Okay? I believe based on this sample, based on this information, table, graphs, and patterns, this is what's going to happen. Okay. So lastly, let's say, for instance, I sample 2 people. Should my measure reliability be better or worse? Well, if I sample 500 people, then my measure reliability should be better than me sampling 2. That's the point here that I need to have a measure reliability attached to my inferential statistic. If I do not have a measure reliability, and that doesn't mean that you see it, that means for me, the person who's doing the statistics, I need to know how reliable my data is. And then I can improve it by doing something or changing or making an adjustment. Okay? That's all.